Tell me inverse functions. Tell me what it means to be an inverse, first of all. Somebody knows this. What about the x and the y? Okay, what about them? What makes it an inverse? I know, just saying random stuff. Inverse means you switch x and y. Yes, that's what it means. It means x and y switch. Okay, so if I have a point, let's say, we'll just be general and say we have the point AB. The inverse of that relation, because remember a relation we talked about yesterday, is just a point, right? It's x and y. The inverse of that relation would be BA. That easy, right? All right, that's in the form of a point. Of course, we're going to be more difficult than that. We're going to talk about in equations. So let's say I have this equation, f of x equals, we'll start out easy, 2x plus 3. How might I find the inverse of that function? What? Tell me what you're doing. Tell me what to do. What does inverse mean? It means switch what? X and y. So f of x is the same thing as what? Y. Do you agree with that? So now if I need to find the inverse, the first thing I need to do is switch x and y. Because that's the definition of inverse, is that x and y swap places, right? So this equation now becomes x equals 2y plus 3. Hey, Jerome. Please. Okay. Now I'm going to solve for y, right? Yeah? Yeah. So subtract 3 from both sides, right? Now how do I get y by itself? Divide by 2. So the new equation exactly is x minus 3 over 2. Now I'm going to write it a little bit differently, and your Algebra 2 teacher might not have shown you this, but this is a little more sophisticated way to write it.
You already know that.
This just means if you have f of x, the little -1 exponent, it just means the inverse of f of x. That's just notation for inverse. Yeah. I did it with my Algebra 2s, but I don't know. Okay? Now I want you to think about something a little bit harder with me. Let's go back to when we were analyzing functions. Okay? What is, and this is a really, really easy one. We'll do a little bit harder one in just a second. What's the domain of f of x? Why? But you don't, that's this continuity. But domain, why is it negative infinity to infinity? What does it not have? Look at the equation. There's two things that restrict domain for us. A fraction or a radical. It doesn't have either one of those. This is a line. It's a linear function, right? So there's no restrictions on the domain. How about the range? Same thing, right? If we think about it, it's a line and it just goes on forever, so the range is negative infinity to infinity. Now, if I wanted to know the domain and range of the inverse, what might I do? Well, you're close. You're thinking along the right lines of switching things. Domain describes what? Left to right, which is x, right? And range describes y, or up and down. So if inverse switches x and y, then the inverse also switches the domain and range, right? Does that make sense? So this one, they're the same, so it's not a very good example, but I'm going to show you on the next one. Okay, now, I have a fraction on this one. Why is it not restricting my domain? It's a fraction.
It's a fraction.
It's a fraction. What's not happening in that fraction?
It's not zero.
What's not zero? The 2 can't be 0. There's nothing I can plug in for x that's going to make that bottom be 0, right? There is no x in the denominator, so it's not restricting my domain at all. Okay? Now, everybody okay on that? Let's do one more algebraically, and then we'll look at it graphically. Uh-oh. Let's say f of x is x squared plus 5. And I asked you to A, find the inverse of the function and find the domain, thank you, Hope. Find the domain and range of the function and its inverse. Okay, so let's do both. Algebraically, what do I need to do to find the inverse? What do you need to do before you minus 5? Change it to y. And then do what? Switch it. Switch x and y around. So this becomes x, this becomes y. Do y'all remember doing this? No? Okay. And now you're ready to subtract the 5. So I move the 5 over. What now? Square root it. So this is really not y anymore. It's, come on. Okay. Yeah. It's always going to be once you solve it. All right, so now that's it. That's it for finding it algebraically. But look at the first one. What's the domain of f of x? Y'all can do this. Come on, come on. You see any fractions or radicals in f of x? What's the domain? Negative infinity to infinity. It's a parabola, right? If you were to graph this, it would look like this. This is 5 right here. And tomorrow we'll start talking about graphical transformations, but it's just a slide up by 5. What is the range then on that parabola? Close. 5 to infinity. The smallest it can be is 5, and then it goes up forever, right? Everybody okay on that? Now, yes. Now, a couple of things are going to change because, yes, domain and range switch places for the inverse, but there's also some additional restrictions as we go through here. What do you think the domain is on the inverse? What switches? The x and y. So what's the domain? Yes. Come on, y'all. Y'all are not with me today. Y'all are not with me at all.
So you're switching the whole entire thing?
Yes. Look, I'm going to graph it and show you.
Oh, wait, never mind.
The square root of x minus 5. What's happening is this thing is rotating about the line y equals x, and it's turning on its side. But because I can't have negative under that square root, the bottom part's not there. Okay. So my range on this one is also restricted. What's the range here? Bottom up. Look at the graph. Look at the graph. 0 to infinity. Y'all got to get with me on this domain and range. All right, look at the inverse. Look at the inverse this graph. Here, put that up. Look at the inverse this graph. The domain is left to right, so 5 to infinity. The range is bottoms up, 0 to infinity. Do you see that? 5 to infinity. There's your domain, there's your range.
How do we get the domain here?
Because you could look at this and say, okay, I can't have, remember, x minus 5 needs to be bigger than or equal to 0. Tell me this. How do you determine if something is a function graphically? If I gave you this graph and I said, is that a function? Would you say yes or no? Why?
It only goes through once.
It only goes through what once, Jackson?
Vertical line test.
The vertical line test. Good job. It passes the vertical line test, right? It only hits, there's never a place you can put a vertical line where it hits more than once. Well, but what happens, what do you think about its inverse? So if I switch every x and y, you're exactly right. It's going to fail once it flips over. It's going to fail the vertical line test, right? That's what the inverse would look like because it's rotated around, it's reflected about y equals x. If every point x, y is switched, this is what it'd look like. All right? And it would fail the vertical line test, right? So while this is a function, its inverse is not a function. How could we, if we use vertical line tests to test functionality, what could we use to test the inverse's functionality? Y'all can get this. Horizontal line test. We can take the same picture and we can say the vertical line test tells me is it a function or not. The horizontal line test would tell me if the inverse is a function. And because while this is a function, its inverse is not a function. Okay? Both? Yes. And those are special functions, and I'm glad you asked that. Functions that pass both tests are called one-to-one. When you start with a function and its inverse is a function, those are called one-to-one. You're exactly right. That one is like that.
And then also, what do the things look like?
Yes, that would be too. That's a cubic. That's a good job. So Jerome said he could think of a line. That would be one-to-one. That is one-to-one. It passes vertical and horizontal. Robert said the thing that goes kind of like this. It's a cubic that's stretched out. That's a terrible rendition of a cubic. But yes, it also would be one-to-one. Right? It passes vertical and it passes horizontal. Does that make sense to everybody? Yes. Go ahead. If y'all need to go, go. I'll put the homework on Classroom. All right, one more thing. I saved the best for last. It's the most involved. Verifying inverse. All right, when I teach this, and I do this in my Algebra 2 class, I don't know if you guys got to this or not if you didn't have me. Verifying inverses is what I like to think of kind of like when you were in geometry and you did proofs. Okay, I'm going to tell you what to start with. I'm going to tell you what the answer is. You justify the in-between, and here's how we do that. If we have two functions that we claim are inverses, so if I told you that f of x was x to the third plus 1, and g of x was the cubed root of x minus 1. Well, we know how to algebraically find the equation of the inverse, right? We switch x and y and we solve for y. That's an easy solve. But to verify inverses, it's a little bit different. We have to show two things. We have to show that f of g of x will simplify down to only x. And we have to show, if my pen will write, that g of f of x also simplifies down. Now, we just did this when we did building functions from functions, when we plug one into the other. Joseph, have y'all gotten to all this yet? I'm sure y'all are probably way ahead of us. We spent some time reviewing. All right, so what we're going to do is we're going to do composition. Remember? Y'all remember composition? Plugging one into the other. So the important part about this is showing every single step in the exact order that it occurs. All right, so order of operations. I promise I'm almost done. I'm going to let you get started work. This is the last thing. My pen started doing this yesterday. F of g of x is the cubed root of x minus 1. So I take f, I do the cubed root of x minus 1, cubed plus 1. Now, I'm telling you everything's going to cancel out. It's just going to. Show me step by step, order of operations, okay? So inside parentheses first, nothing happens, right? Right. Say right, because that's right. Okay, and then, so now exponents. Well, look at this exponent, this radical. Do you agree those are opposites and they cancel? Yeah. So cancel those out. Those are gone. So, and one thing at a time, yes, the ones are going to cancel, but you got to cancel them in the right order. So now I have x minus 1 plus 1. Now what cancels? The ones. So it verifies forward. Now I have to verify backwards. And you have to show both of these every single time. G of x cubed plus 1. So the cubed root. It's not x anymore. It's x cubed plus 1. And then I got that minus 1 up there. What cancels first? The ones. The ones because being under a radical groups together. So that's like being in parentheses together under that radical. So the ones are going to go first. And then your 3's will go, which leaves you with just x. Correct.